Chapter 1. Evolution of Modern Computers. Learning Targets. History of Computers. Early Calculating Devices. Generations of Computers. Characteristics of a Computer. Limitations of a Computer. We live in a time when machines and technology are a big part of our lives. One of the most important machines is the computer. Today, we can say that computers are everywhere. A few decades ago, computers were not as advanced and were mostly used by scientists in special labs. They were not common for everyday people. Now, computers are used by almost everyone. You can find them in hospitals, banks, schools, homes, airports, and train stations. There are very few places where computers are not used. In this chapter, you will learn about the history of computers and how the modern computer was developed. History of computers. Today's computers are multitasking machines. They can do many different tasks at the same time without any problems. In earlier times, there were different types of calculating devices used for performing calculations. The first calculating device was the abacus. Since then, many other devices have been invented, helping to develop the computers we use today. In the next section, you will learn about some important early calculating devices. Early calculating devices. Abacus. The abacus was the first calculating device invented in China around 3000 BC. It was made up of a wooden frame with vertical rods, each holding beads. It was used to perform simple calculations like addition, multiplication, subtraction, and division. It is still used today in parts of Asia and Africa. Napier's bones. This device was made in 1616 by a Scottish mathematician named Sir John Napier. It had numbers carved on bones or wooden strips. Napier's bones were used for calculations like addition, subtraction, multiplication, division, and finding square roots. Pascaline calculator. In 1642, Blaise Pascal invented the first mechanical calculator called the Pascaline. It was a rectangular box with movable wheels. The Pascaline could perform basic arithmetic operations like addition and subtraction. Leibniz calculator. In 1671, the famous German mathematician Gottfried Wilhelm Leibniz improved on Pascal's machine. The Leibniz calculator was a mechanical device. Besides addition and subtraction, it could also perform multiplication, division, and find square roots. Difference engine. The difference engine was invented in 1822 by Charles Babbage, who is regarded as the father of computers. It was an automatic mechanical calculator that could create error-free mathematical tables. Analytical engine. The analytical engine was also invented by Charles Babbage in 1833. It is considered the first general-purpose computer. This device had three basic elements: input, output, and memory. The way modern computers work is based on the ideas from the analytical engine. The analytical engine included 4 units: store to hold data, mill, the calculating unit, reader, input device, and printer, output device. Tech fact. First computer, program 1841. The world's first computer programmer, Ada Lovelace, began translating Luigi Menabrea's Italian mathematician records on Babbage's analytical engine. In 1841, she understood how to make the machine perform tasks like modern computers do. Lovelace suggested a way to input data that would allow the machine to calculate Bernoulli numbers. Tabulating machine. The tabulating machine was invented in 1880s by Herman Hollerith, an American statistician. This machine could read data, process it, and produce the desired output. Punched cards were used for input and to record and store data. Generations of computers. The generations of computers are based on the development of technology used in computing. First generation computers, 1940 to 1956. First generation 1G computers were based on vacuum tubes. They were large and took up a lot of space. These computers had small internal storage and were quite slow. They required constant maintenance. First generation computers were very expensive. Punched cards and paper tapes were used to input data. Magnetic tapes were used as secondary memory. The operating system used was the batch operating system. Machine language was used in this generation of computers. Examples of first-generation computers include Mark I, ENIAC, Electronic Numerical Integrator and Computer, UMEVAC, Universal Automatic Computer, and EDVAC, Electronic Discrete Variable Automatic Computer. Mark I. Professor Howard Aikens built the first electromechanical powered computer named Mark I in 1944. Mark I was the first fully automatic calculator. It used punched cards and a typewriter for input and output. Mark I was much more reliable than early electronic computers. ENIAC. ENIAC, Electronic Numerical Integrator and Computer, was the first fully electronic general-purpose digital computer. It was invented by John Mauchly and John Presper Eckert in 1946. This computer used 18,000 vacuum tubes, which made it 1,000 times faster than the Mark I. ENIAC could add two large numbers in just 200 microseconds. ENIAC. EDVAC. EDVAC stands for Electronic Discrete Variable Automatic Computer. It represents a modern type of computer created with software developed by John von Neumann. This software was written in binary code. John von Neumann started the practice of storing both data and instructions in memory as binary code. In 1950, with the help of Presper Eckert, an American electrical engineer, and John Mauchly, an American physicist in a consulting role, John von Neumann developed EDVAC using binary code. EDVAC was basically an improved version of ENIAC. UNIVAC. Universal Automatic Computer was another successful invention of John Mauchly and Presper Eckert. It was developed in 1951. UNIVAC was the first computer capable of handling both numeric and textual data. The machine had 5,200 vacuum tubes. It was the first electronic computer that was commercially available. Second-generation computers, 1956 to 1963. Second-generation 2G computers used transistor technology. These computers were smaller, consumed less power, and were less expensive than the first generation. They were faster and more efficient than first-generation computers. Second-generation computers had larger storage capacities. They used punched cards and magnetic tapes as input devices, and output was displayed on printouts. These computers used assembly language and programming languages like Fortran, BASIC, and COBOL were used to write programs. However, they were not versatile and were mainly used for specific tasks. Examples of second-generation computers include IBM 1401, IBM 350, UNIVAC, RCA 501, NCR 300 series, and others. Third-generation computers 1964 to 1971. Third generation 3G computers used integrated circuits, commonly known as chips. A single chip could contain thousands of transistors, making these computers smaller than second-generation computers. They were faster, cheaper, and more efficient. This generation of computers used magnetic disk for secondary memory. They use keyboards as input devices and monitors and printers as output devices. Third-generation computers utilized operating systems, allowing them to run multiple applications at the same time. Examples of third-generation computers include IBM 360 series, IBM 370 series, ICL 1900, UNIVAC 1108, Apple I, and UNIVAC AC 9000, among others. Tech fact: the integrated circuits IC was invented by Jack Kilby. Fourth-generation computers 1972. Present. The fourth-generation 4G computers are the ones we use today. These computers use very large-scale integrated circuits, VLSI, known as microprocessors. In addition to monitors and printers, new devices like plotters and speakers have become common output devices. Fourth-generation computers are smaller, more efficient, reliable, powerful, and capable of multitasking. Examples of fourth-generation computers include desktop computers, Apple Macintosh, IBM PC, and others. Tech Info. The development of microprocessor technology brought a revolution in the generation of computers. Microprocessors combine thousands of integrated circuits onto a single silicon chip using VLSI, very large-scale integration, and ULSI, ultra-large-scale integration techniques. An IC, integrated circuit containing about 100 components, is called LSI, large-scale integration. An IC containing more than 1,000 components is called VLSI, very large-scale integration. Fifth-generation computers, present, future. Fifth-generation 5G computers use ULSI, ultra-large-scale integration chips. These computers have extremely large storage capacities and high processing speeds, making them some of the most powerful computers ever created. Therefore, they are often referred to as supercomputers. Because of these capabilities, 5G computers are used in areas like weather forecasting, research and development, and so on. This generation of computers is based on artificial intelligence, AI. AI is a branch of computer science focused on making computers think and make decisions like humans. Fifth-generation computers aim to possess human-like intelligence and reasoning abilities. These computers are still in the development stage. Examples of fifth-generation 5G computers include Cray AS C300, Cray 1, Peram, Tianhe 2, and others. Tech fact: the first supercomputer of India was Peram 8000 year 1991. Tech info: Sophia is a humanoid robot powered by artificial intelligence (AI). It was developed by Hanson Robotics, a company based. Characteristics of a computer: a computer has certain characteristics that set it apart from other machines. Speed: a computer works very quickly. Its speed can be measured in instructions per second. A computer can perform large numbers of calculations in just a fraction of a second. Accuracy: computers are highly accurate in their calculations. If the input is correct, the output is likely to be right. Diligence: a computer does not get tired and can work for long hours without breaks. It can repeat the same tasks over and over with the same speed and accuracy. High storage: modern computers can store large amounts of data and programs for future use. This data can be easily retrieved whenever needed. Versatility: modern computers can perform a wide range of tasks. They are used in homes, hospitals, banks, offices, and schools for various activities. Connectivity: computers are connected all over the world, forming a global network known as the Internet. This connection allows millions of computers to exchange information and communicate effectively. Limitations of a computer: a computer is a powerful machine, but it has some weaknesses. Some of those are: 0 IQ. A computer has no intelligence or IQ, intelligence quotient of its own. It only works based on the instructions it receives. For example, if the input is wrong, the output will also be wrong. Lacks decision-making power. A computer is not capable of taking any decision on its own because it cannot think. When faced with unexpected situations, it may produce incorrect results or stop working altogether. No heuristics. Heuristics is the ability to learn from past experiences and make better decisions. Computers lack this ability, so they cannot adapt to new situations or improve on their own. They need human help to make changes. Note: AI helps overcome the no heuristics limitation by enabling computers to learn from experience and adapt their behavior. Wrap up: the abacus was the first calculating device. Other early calculating devices included Napier's bones, the Pascaline, the difference engine, and the analytical engine. The difference engine and analytical engine were invented by Charles Babbage. ENIAC was the first general-purpose electronic digital computer, invented in 1946. First-generation computers were based on vacuum tubes. Second-generation computers used transistors in place of vacuum tubes. Third-generation computers were based on integrated circuits. Fourth-generation computers are based on microprocessor. Fifth-generation computers are based on artificial intelligence, power of human intelligence and reasoning. Computers are fast, accurate, diligent, have high storage, and are versatile. Computers cannot think or make decisions and cannot learn or adapt without human help.